Okay, so in this example, and these three examples actually, you guys were given f of x equals 1/3 of the x and asked to graph that. I've already done that. Now, this 1/3 to the x is actually the parent function for these next two examples. So if I took away any other thing that was getting added or subtracted or multiplied to this base raised to the x, I'm left with f of x equals 1/3 to the x. So the transformations that are taking place for this graph here is this is telling me that it's going to go up 3, and now I have a negative here, which means it's going to be reflected about the x-axis. So the first thing that I'm going to do though is I'm going to take care of this up 3, because that's telling me that my horizontal asymptote is going to be y equals 3. So here's my horizontal asymptote. Now my parent function remains the same. So if I have -1, 0, and 1, the only thing that's happening now is that I now need to multiply all of my y coordinates by that -1. So they become -3, -1, and -1/3. So I'm now going to graph these points that I get from this table, but from the new origin. So the only shift I had was that up 3. So it's this x that I pretend like is my new origin. And so from there, I'm going to go left 1, down 3 as indicated in my table. I'm going to start back at the new origin, just go down 1, and then right 1, down 1/3. And so this is what it looks like when we take an exponential decay function and we reflect it. Now, this last example is far more interesting because it has not only a vertical stretch by a factor of 3, it has a horizontal shift and a vertical shift. So the parent function for this is still going to be 1/3 to the x So I'm going to first start by using my vertical shift to find my horizontal asymptote. So I know my horizontal asymptote now is y equals -5. Okay. So my shifts are telling me that not only did I go down 5, but I'm going to go left 4. So if I go left 4 and down 5, I find myself at my new origin. Well, I also have a vertical stretch by a factor of 3. So if I multiply all of my y coordinates by 3, I'm left at 9, 3, and 1. So I go to my new origin, and I'm going to go left 1, and then I'm going to go up 9 from there. So if I go up 9 from there, I have a point. Then if this is 0, 0, I would just go up 3. And then I would go right 1, up 1. And so this is now the graph of the transformed function. So in summary, what I would do if I were you guys is I would find the parent function, state the parent function, and then, well, create a table for it. Determine your horizontal asymptote and the location of your new origin. And then if you have a vertical stretch, compression, reflection over the x-axis, multiply your y-coordinates by that number, and then sketch those points from that new origin. And this is really similar to what we did with all of our parent functions earlier. So I hope this video helps, and I will see you guys soon.